Hello and welcome to my video on completing the square. How to express a quadratic function or equation in completed square form. So the standard form of a quadratic function is ax squared plus bx plus c, where a, b and c are constants, and of course a cannot be equal to 0 because there must be an x squared term in order for it to be a quadratic function. The completed square form of a quadratic function or expression is as follows: a multiplied by x plus h all squared plus k, where a, h and k are constants, and again a cannot be equal to 0. I'd like now just to make a plug for this website, www.mathsisfun.com. They do an excellent job of explaining many mathematical topics, including this one, completing the square. Anyway, let's proceed. First thing I'd like us to remember is when we say x plus 2 all squared, what do we do? What is our result? Well, that is equal to x plus p multiplied by x plus p, which gives us x squared plus 2px plus p squared. If you don't know how we got this, then I recommend that you look at another video on FOIL, F-O-I-L, and on multiplying two terms in brackets. What about x minus p all squared? Well, that is x minus p multiplied by x minus p, which is equal to x squared minus 2px plus p squared. Please note that the final term for both squared expressions is plus p squared, notwithstanding the negative signs in the second expression. And why is this so? Well, because negative p by negative p is positive p squared. There it is. So let's replace p with some numbers. How about 5? X plus 5 all squared is equal to x plus 5 multiplied by x plus 5, which is equal to x squared plus 10x plus 25. And what about x minus 3 all squared? Well, that's equal to x minus 3 multiplied by x minus 3. Please remember to maintain your parentheses, which is equal to x squared minus 6x plus 9. Well, let's look at what's going on here. Let's take these expressions here on the right hand side and put them here underneath our general form, because as you can see, this looks rather like ax squared plus bx plus c. In this case, a is equal to 1, b is equal to 10, and c is equal to plus 25. And in this case again, a is 1, b is negative 6, and c is positive 9. Well, do we have a completed square form? And as a matter of fact, we do. X squared plus 10x plus 25, here it is equal to x plus 5 all squared. Well, a is 1, h is 5, and k is 0. And here again, we have a is 1, h in this case is negative 3, and again, k is 0. Well, there should be some things that you observe at this point. First thing I observe is that 5 is half of 10, and that negative 3 is half of negative 6. So it occurs to me that h, in this case, is equal to b over 2. It's half of b. It also strikes me that 5 squared is equal to 25, and negative 3 squared is equal to 9. So it looks here like c is equal to h squared, but we just said that h was b over 2, which means that c is equal to b over 2 all squared. Alright, so let's practice a bit. If I give you the general form, can you express it in completed square form? And we're only going to look at perfect squares. Well, what's half of 2? 1. The square of 1 is 1. So the completed square form of x squared plus 2x plus 1 must be x plus 1 all squared. What about x squared plus 4x plus 4? Half of 4 is 2. Remember we said h was half of b. And c was half of b squared. So this is definitely a perfect square. So the answer is x plus 2 all squared. Now you try the rest on your own. Did you get half of 6 equal to 3? There you go, and 3 squared is 9. Half of 14 is 7. 7 squared is 49. I hope you did not let this fraction throw you off. What's half of 3? Well, it's 3 over 2. And 3 over 2 squared is 9 over 4. Remember, it's 3 over 2 multiplied by 3 over 2, so it's 9 over 4. Please, fractions are our friends. Please leave them as improper fractions. Please do not put decimals. Here's another. Here's my plea for improper fractions. Fractions are friends. Leave the calculator alone. Let's use our brains. Let's do a bit more. What about when we have a negative sign in here? Remember, x minus p all squared was equal to x squared minus 2px plus p squared. That's right. So the completed square form is x minus 1 all squared. And the completed form, square form for x squared minus 4x plus 4 is x minus 2 all squared. And I'm sure by now you're starting to kind of get the rhythm, get the pattern, see what's going on. Please do pause the video in between so you can stop, work the answer out, and then check. All right, great. Now, how about we change our original function a bit? How about for our general form, instead of saying x squared plus 2x plus 1, which is a perfect square, and we know that's equal to x plus 1 all squared, suppose we just have x squared plus 2x. Well, all I did was subtract 1 from this side of the equation. And that's easy to deal with. I know that whatever I do on one side of the equation, I must do on the other side of the equation to maintain equality. So that has to be true. It has to be true that x squared plus 2x is equal to x plus 1 all squared minus 1. What about this one? Instead of x squared plus 6x plus 9, which is equal to x plus 3 all squared, what if I just had x squared plus 6x? Well, yes. Well, in that case, my right-hand side is x plus 3 all squared minus 9. What about x squared plus 3x plus 9 over 4? That's equal to x plus 3 over 2 all squared, but what if I didn't have the 9 over 4 on the left-hand side? Well, then I've got to subtract it from the right-hand side. Let's just look at a few more, because this is really important. Instead of x squared minus 2x plus 1, I just want x squared minus 2x, which therefore means that I have x minus 1 all squared minus 1 as my completed square form. Instead of x squared minus 16x plus 64 being equal to x minus 8 all squared, what if I only had x squared minus 16? That's right, I've got to subtract 64 from x minus 8 all squared. What about this nice fractions fellow? If I only have x squared minus 7x, then the completed square form must be x minus 7 over 2 all squared minus 49 over 4, which of course is a square of 7 over 2. It's the square of negative 7 over 2 actually. So, because remember we are subtracting the square. So what did you notice about the k term in the completed square form when the c term in the general form is 0? Well, here we go. If we had x squared plus 6x, the completed square form was x plus 3 all squared minus 9. Well, look at that. K was equal to negative of b over 2 squared. B was 6. 6 over 2 is 3. 3 squared is 9 minus 9. And that's just subtracting c from both sides. Remember we said that c was equal to b over 2 all squared? This is a really very useful result. It's telling me that I can take any x squared plus 2px term and express it as x plus p all squared minus p squared. And this is the core of our completed square method. Now you try some without any prompts. You're going to take half of the b term and subtract its square. Please be careful with your pluses, your minuses. Don't be afraid of your fractions. You notice how the minus matches a minus, the plus matches a plus, minus a minus, but all of these are minus the p squared. Remember that came from the fact that x minus p all squared was x squared minus 2px plus p squared. And then I'm getting rid of the p squared here. So all of these are minus p squared. Okay, so we're getting there. Let's change our original function a bit more. X squared plus 2x. Yeah, we're good with that. I know what to do with that. What happens when I have a random minus 3 at the end of it? Well, I am concerned with my x squared and my x terms. I know what to do with those. I know that x squared plus 2x is equal to x plus 1 all squared minus 1. So these two yellow terms are equivalent. So the only thing throwing off the equality is the fact that I've got minus 3 on my left-hand side. Well, that's easy to deal with. Just put minus 3 on my right-hand side and I've got a balance. The only thing here now is that I have to simplify the constants. I've got two constants. I'm not going to leave them separate. And so we have that x squared plus 2x minus 3 is equal to x plus 1 all squared minus 4. Neat. Let's try another. So I have x squared minus 16x. Then I've got this plus 28. No worries. I know what to do with x squared minus 16x. I know that that is equivalent and equal to x minus 8 all squared minus 64. Maintain the balance by adding 28 to my right hand side. Simplify the constants. Hey presto. X squared minus 16x plus 28 in completed square form is x minus 8 all squared minus 36. What about one with fractions? So I have x squared plus 5x minus 6. Again, the minus 6 is not bothering me. Leave it alone. Let's deal with x squared plus 5x. I can deal with that. I know how to take half of my b coefficient. So x plus 5 over 2 all squared minus the square of this, which is 25 over 4. But now I've got to balance it by including the minus 6. So let's simplify. I've got two constants. I need to simplify them. So x plus 5 over 2 all squared minus 25 over 4. I've got an integer, a whole number, and a fraction. I've got to express this in equivalent fraction form. which would be negative 24 over 4, because 4 into 24, of course, is 6. So let's simplify my constants. So x squared plus 5x minus 6 is equal to x plus 5 over 2 all squared minus 49 over 4. Leave it as an improper fraction. And the thing is, you can check. If I multiply and expand out my right-hand side, the completed square form, I must get back to my general form. So let's see. X squared plus 2px, so 2px plus p squared minus this extra constant at the end here, 49 over 4. So I've got x squared plus 5x minus 25 over 4, which is in fact 6. So x squared plus 5x minus 6. There we go. We were correct. So how about you practice now? Remember, I'm only concerned with my x squared and x terms. Leave the constant for the end. Great. I hope you got them all correct. And if you didn't, no worries. Go back, check the explanation again, and try them again. So we have one more change to our original function. What happens when a is not equal to 1? So suppose I have 2x squared plus 4x minus 7. A is equal to 2. And I've got to get that in completed square form. Well, I only see an x in here. I'm not interested in a coefficient of x in here. So when x is not equal to 1, factorize it from the x squared and the x terms. Leave Mr. Constant in peace, but remove the 2 from both these terms. How do I do that? With the use of brackets, of course. I personally like to use square brackets since I know that I'm going to be using parentheses later on. So 2 multiplied by open square bracket x squared plus 2x closed square bracket minus 7. Well, let's just double check. 2x squared, 2 by positive 2, 4x. Beautiful. Do I know what to do with x squared plus 2x? Yes, I do. So I leave my 2 and my square brackets. And I know that x squared plus 2x is equal to x plus 1 all squared minus 1. Well, so all I have to do now on my right-hand side is simplify. Just neaten it up, clean it up. So let's get rid of those square brackets. Multiply the 2 throughout. So it's 2 multiplied by x plus 1 all squared. 2 by negative 1 is negative 2. Bring down that negative 7. Simplify those constants. And we have 2x squared plus 4x minus 7 is equal to 2 into x plus 1 all squared minus 9. 2 multiplied by x plus 1 all squared minus 9. You can pause now and check by expanding the right-hand side. Check and see if we were right. And let's try another one. What about 3x squared minus 12x plus 8, where a is equal to 3? And I've got to get it in that completed square form. Well, factorize a from the x squared and x terms. So 3 open square bracket x squared minus 4x closed square bracket plus 8. I know what to do with my x squared minus 4x. Keep the 3 and the brackets. X squared minus 4x is x minus 2 all squared minus 4. Remember the plus 8 to balance the equation. Multiply through my square brackets. I've got 3 multiplied by x minus 2 all squared. 3 by negative 4 is negative 12. I bring down my plus 8. Simplify my constants. And 3x squared minus 12x plus 8 is equal to 3 multiplied by x minus 2 all squared minus 4. What about when a is negative? Suppose we had negative x squared plus 6x minus 25. Well, all that means is that a is equal to negative 1. Remember, the 1 there is implied. You don't actually have to have written the numeral 1. So factorize negative 1 from the x squared and x terms. And remember to leave the constant alone. Now here, you need to be careful. One of my favorite sayings is respect the negative sign. So when I factorize out negative sign from positive 6x, I am left with negative 6x. So let's check. Negative by x squared is negative x squared. Negative by negative 6x is positive 6x, correct? And then I leave my constant in peace. Well, I know what to do with x squared minus 6x. So I bring across my negative and my square brackets. I know that x squared minus 6x, half the coefficient of negative 6 is negative 3. So it's x minus 3 all squared minus 9, which is the square of negative 3. And of course my negative 25. To balance the equation, multiply it through and simplify. I've got negative multiplied by x minus 3 all squared. And here, again, be careful. Negative by negative 9 is positive 9 minus 25. And here I have that negative x squared plus 6x minus 24 is equal to negative into x minus 3 all squared minus 16. Let's just try one more when a is negative. What about negative 2x squared plus 10x minus 13, where a is negative 2? Factorize the negative 2 from x squared and x. Leave the constant alone. Use your square brackets. Be careful when factorizing out a negative number. Negative 2 by negative 5 is positive 10. Deal with your x squared and x. Bring over the negative 2 on the square brackets. Keep it neat, error-free. I know that x squared minus 5x is equal to x minus 5 over 2 all squared minus 25 over 4. Multiply through the square brackets with the negative 2. So negative 2 multiplied by x minus 5 over 2 all squared. But negative 2 by negative 25 over 4 is plus 25 over 2. I must take my negative 13 and express it as an equivalent fraction with the same denominator so that I can simplify these two constants. And so negative 2x squared plus 10x minus 13 is equal to negative 2 multiplied by x minus 5 over 2 all squared minus 1 over 2. Okay, now it's your turn. This is a pretty quiet part of the video because really I just want you to pause, work it out for yourself, and check your answer. Okay, and that's it. Now you just need to practice, practice, practice. I recommend that you try the questions at the Math is Fun site. And you can also make up your own. You can write any quadratic expression in completed square form. So you can make up questions for your friend can make up questions for you. And remember, you can check your own answer simply by expanding the completed square form. Stick with fractions, improper fractions. Now, just for the sake of completeness, I want to generalize what is going on when we complete this square. So we start with our general form of a quadratic function or expression, ax squared plus bx plus c. And I want to express it as a multiplied by x plus h all squared plus k. Well, what do? I've got to factorize the a out of the x squared and x terms. So I have a, open square bracket, x squared plus b over ax, close square bracket, plus c. I know how to express this in completed square. I take half of this coefficient, which is then b over 2a. So I have a, open square bracket, x plus b over 2a all squared minus the square of b over 2a, close my square bracket, plus c. And then I simplify. So a multiplied by x plus b over 2a all squared minus what? I've got to multiply this a by this term. A multiplied by b over 2a all squared plus c. And when I simplify, it turns out that ax squared plus bx plus c is equal to a multiplied by x plus b over 2a all squared minus b squared over 4a, because of course 2a squared would have been 4a squared, but you cancel a here, plus c. So what does this tell me? It tells me that this a is equal to this a. It tells me that h is equal to b divided by 2a. And it tells me that k is equal to this entire expression here. But you know, you really do not need to memorize that. Just remember that completing the square comes from these two basic square expressions. That x plus p all squared is equal to x squared plus 2px plus p squared. And that x minus p all squared is equal to x squared minus 2px plus p squared. And if you follow the logical sequence of this video and practice, you will soon be able to change any quadratic expression into completed square form in your sleep. Well, I hope that was helpful. Goodbye until next time.